We'll see what happens. 3.1, derivatives of a function. So a derivative, the derivative of a function f with respect to, so don't forget WRT is with respect to the variable x is the function f prime, so it's like a little f apostrophe, whose value at x is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, provided the limit exists.
So it's kind of similar to what we did
Last year. This is basically what we did last year. This is the limit definition. I mean, sorry, the definition of a derivative, but the limit definition of a derivative, I guess I should say.
Yeah.
Which is what we did, but then I taught you the shorthand way that we won't learn until like the next section, but technically, ahead of the game a little bit.
I'm glad we did this last year. Now it's not like that boring.
Yeah, well, it'll be easier to pick up. If f prime of x exists, we say f has a derivative, or we would say is differentiable, at x. If a function is differentiable at every point in its domain, it is a differentiable function. Next, the derivative at a point. So this is going to be another definition. So the derivative of a function f at point, or at the point x equals a, is, hold on, I want to make sure that's written right. Is the limit f prime of a is equal to the limit as x approaches a, so that's whatever the point is, f of x minus f of a all over x minus a, provided the limit exists. Ways to denote derivatives. So we can do There's going to be 4 of them, or 4 primary ones. So we can do y prime and that would be the same as like the f prime of x or whatever. We can do dy dx, and that's the way I would say it. It's dy over dx, which is the derivative of y over the derivative of x, which basically just means the derivative of y with respect to x. So anyways, df dx, and then d dx of f of x. So that's just a way of saying the derivative of f of x. The primary ones we're going to use are this y prime and dy dx. So this is y prime, and this is derivative of y with respect to x. You'll very rarely see me use the other option, and even the book doesn't really ever use the other option. They only would really use d dx probably if the function wasn't like y equals something and it was like, you know, t equals something weird. They would do that, but and there's some stuff about like how to graph the derivative of the function if you are given the function in general. So we'll look at that more with pictures at a different point, but just wanted to let you know that that is a thing. And then the last note thing, kind of long, but not super long, is one-sided derivatives. So we've had one-sided limits, now we have one-sided derivatives. So y equals f of x is differentiable on a closed interval a to b if it has a derivative at every interior point of the interval if the limits, there's going to be 2 of them, so the limit as h approaches 0 from the right, so we still write the same way like we did in the other one, of f of a plus h minus f of a all over h, and the limit as h approaches 0 from the left of f of a plus h minus f of a over h exists at the endpoints. And so kind of like we had when we were determining the stuff with the limits, like the one-sided limits and then the two-sided limit and stuff, if the limits are not the same, okay, the function does not have a derivative at that point. So they would have to match to have a derivative at the point. All right, that's all the notes for that section.